Not long ago, artificial intelligence was a novelty, a chatbot generating text on a screen. Today, that digital abstraction has taken on solid weight. It is being laid down as the invisible foundation of the modern economy. Organizations have stopped debating whether they should adopt these tools. The only question they ask now is how fast they can scale them across their supply chains and compliance systems, without breaking the operations they already have in place. We have officially exited the experimental pilot phase. The industry has moved into a period defined by what engineers call agentic AI. Past software was passive. It waited for a human to type a prompt. Agentic systems operate like digital workers. They analyze their environment, reason through complex objectives, and autonomously execute multi-step plans, learning from their own feedback loops as they go. Think about the massive build-out of electrical grids in the 20th century. Factories didn't treat electricity as a single product to buy. They treated it as a utility required to keep the lights on and the machines running. Intelligence is now that utility. When success is measured in measurable return on investment rather than simple adoption rates, it becomes a mandatory resource for running the systems of global commerce. This intelligence utility is rapidly breaking out of our screens and entering the physical workforce through commercial humanoid robots. We are seeing actual industrial pilots right now. Figure AI robots are placing sheet metal at BMW facilities with millimeter precision, while Elon Musk's Tesla is aggressively training its Optimus robots to navigate active factory floors. These machines rely on multimodal AI, systems that process audio, video, and tactile force all at once. This allows a robot to see a chaotic environment, hear a command, and instantly adjust its grip strength in real time. This same logic of industrial efficiency has extended into the life sciences. The utility is now actively rewriting the instructions inside living cells. Researchers are using AI for de novo protein design, creating entirely new functional proteins built from scratch in just weeks. They are even generating specific genetic inhibitors, essentially smart scissors, that control CRISPR technology to prevent unwanted DNA damage during treatments. The impact of these models is no longer confined to server racks. They are directly manipulating the cars we drive and the molecular structure of our bodies. There is, however, a massive physical bottleneck threatening this entire build-out. It requires staggering amounts of raw electricity. This chart shows the projected annual electricity consumption for global data centers, surging toward the 1,000 terawatt-hour mark. To put that into perspective, if the data center sector were its own country, that 1,000 terawatt-hour demand would equal the total energy consumption of Japan. This massive load is straining traditional utilities, causing wait times for new grid connections to stretch up to 5 years. In response, tech giants are bypassing local power grids entirely by adopting bring-your-own-power strategies. To secure operational resilience, these companies are building independent microgrids, financing their own natural gas plants, investing in modular nuclear reactors to keep their servers running. Ironically, the only viable way to manage the strain these systems place on the grid is by using the systems themselves. Utilities use flexible AI optimization to forecast weather patterns, integrate wind and solar, and orchestrate energy loads in real time. The ceiling on what a digital brain can achieve is strictly limited by how much electricity we can physically pull out of the earth to feed it. Because intelligence functions exactly like electricity, governments have realized that relying on a foreign power for their computing capacity is a massive national security risk. This has triggered a global race for sovereign AI. Nations are scrambling to construct domestic data centers and train local models to ensure they have total control over their own technological infrastructure. The United States is pouring billions in private capital into initiatives like the Genesis mission, attempting to lock in its scientific and hardware dominance. China, meanwhile, leads the world in AI patent grants, focusing intensely on rapid commercial implementation and industrial hardware. The European Union is taking a different route, prioritizing strict regulatory frameworks while heavily funding domestic supercomputers to reduce reliance on foreign tech. And countries like the UAE and Saudi Arabia are leveraging their massive energy resources to weave these models directly into their national infrastructure. Server capacity and compute clusters have replaced oil and steel as the ultimate metric of a nation's geopolitical sovereignty. This national-level integration is already filtering down to the labor market. In the US, we are seeing real GDP growth driven by productivity gains rather than payroll expansion, creating a low-hire, low-fire environment. This shift is so structural that the Chief AI Officer has transitioned from an experimental title to a board-level requirement. Externally, the sheer volume of hyper-realistic synthetic media is creating a crisis of trust, a widespread reality collapse where users can no longer trust their own eyes when looking at a screen. To combat this, the industry is establishing new digital standards, like C2PA, which embeds secure, traceable metadata directly into files, so users can verify exactly where a piece of content originated. The experimental gold rush is over. We have entered the messy, expensive phase of laying down the permanent, invisible pipes and wires that will operate society for the next century.